So now let's look at some systems of equations where we don't really know what's going on. It's nice when we have a word problem and we actually know what those variables represent, but for the most part we're probably going to be looking at systems of equations where we have two variables and we don't know what they represent. We can still find a solution. Remember, a solution is an ordered pair that makes all of the equations that we're working with true, and a system has two equations using the same variables. So we're going to first solve these equations by graphing. So to graph them, we're going to find the slope and y-intercept of each of the equations. That's probably the simplest way to graph a line, a linear equation. And then we're going to graph each equation and find the point of intersection. So we're going to look where those 2 points, those 2 lines meet each other. So let's start with this first system. Y equals x minus 3 and y equals negative x plus 1. So I'm going to take each one of those equations and I'm going to find the y-intercept and the slope. So for my first one, it's in slope-intercept form. So I know my y-intercept is negative 3. It's that number at the back there. And I know that my slope is the number in front of the x. So that is a 1. My second equation is also in slope-intercept form already. Y equals mx plus b. So I know my y-intercept is that plus b at the end. So the y-intercept is 1. And I know my m in mx is my slope. So it's a negative 1 in front of my x there. So we're going to graph each of these equations. So first I graphed my y-intercept of negative 3 down here. And then I graphed a slope of 1. So rise of 1, run of 1. Rise of 1, run of 1. And notice I'm making a lot of dots as I go. I'm going to fill up with a whole bunch of dots because what I'm hoping is that my other line has a dot that lands in the same place. So we're not going to do as we were doing before when we were graphing, which was just get a few points and then just kind of draw the line. We want to do as many dots as we can to make sure exactly where those 2 lines meet. So now I'm going to take my second equation. I'm going to graph my y-intercept of positive 1 here and a slope of negative 1. So that means I have a rise of negative 1, a run of 1, negative 1, 1, and there it is right there. That's where they run right into each other, right here at this ordered pair, which is 2, negative 1. So 2, negative 1. Now, these are really easy to check also. We've done this when we were graphing equations before. An ordered pair should work in each of these equations. So this ordered pair, if I made 2 tables, this ordered pair would show up in both of the tables for these 2 equations. But I should be able to check them. So let's try this. 2 minus 3, if I put 2 in for x, 2 minus 3 is negative 1. So that works. If I use this as my input, I get negative 1 as my output. Let's try it with the other one. The opposite of x, so the opposite of 2, that would be negative 2. Negative 2 plus 1. Negative 2 plus 1 is negative 1. So I do get an output of negative 1. So there's my solution for this system of equations. All right, let's look at one more. So I have this system, y equals 2x plus 3, and 4x plus 2y equals 6. So this first equation here is already in slope-intercept form, which makes it very easy to graph. So my y-intercept is 3 and my slope is 2. So on my coordinate plane here, I'm going to go up to 3 on the y-axis and do a slope of 2, so up 2 over 1. Notice I kind of ran out of coordinate plane here, so I went backwards. I went down 2 and back 1, down 2 and back 1. That gives me the same pattern. And notice I did a whole bunch of points here so I could figure out where they meet. Now my second equation is not in slope-intercept form, so I'm going to have to do some work to get it to be into slope-intercept form. So I want to get the 2y by itself first, so I'm going to subtract 4x from both sides. So I have 2y equals negative 4x plus 6. I want to get the y by itself. I'm going to divide by 2, so I'm going to divide each of these by 2. So I get y equals negative 2x plus 3. So here's my equation. Y equals negative 2x plus 3, has a y-intercept of 3, and a slope of negative 2. So when I go to graph this, I notice right off the bat that the y-intercepts are the same. So that's the ordered pair where they meet. So here's my y-intercept. I'm going to graph this line to see what they look like. It has a slope of negative 2. So a rise of negative 2 and a run of 1. A rise of negative 2 and a run of 1. So these 2 lines, these 2 equations meet, they intersect at this point here on the y-axis. This ordered pair is 0, 3. So the solution to this system is 0, 3. So how this works, if I plug in 0 for my x, I should get 3 for my y. So 2 times 0 is 0 plus 3. That equals 3. Let's try 0 and 3 in this one. 4 times 0 is 0, plus 2 times 3. 2 times 3 is 6. 0 plus 6 is 6. Is 6 equal to 6? Yes, it is. So this ordered pair works in both equations, so it is the solution for our system.